rehearsals. So just to say, I'm going to be talking about the business changes that London has that we expect to incorporate into our future technology roadmap, and Peter will pick up on the technology itself, the types of technologies that are available to us. I hope, despite all of the technical problems that we've had, that there is a question session now running about the things that are happening in our marketplace, and I would like to know what you feel is the next bit of passenger information, the most important passenger information that we should have and take forward. Hopefully that's working okay. Right then, so the agenda that I'm taking you through is a little bit about TfL, the introduction to how we work, our business model and technology landscape, scale of operations, and then go into detail on those challenges. As I said before, the TfL it's not a bus operator as such. It's a transport authority looking to provide and implement the bus service that for the elected Mayor of London, Sadiq Khan. That's his Deputy Mayor, Heidi Alexander, and that's controlled by the head of TfL, our Commissioner, Andy Byford. And my point about bringing up about Claire Mann was that Claire Mann is now our Director of Bus Operations. And for the first time, she's not really somebody who's come from an engineering background. Claire has a history in people and working with people and customers, and she is now heading up the bus operations business and is bringing a completely different customer focus to our operations. Going forward, if I was just describing there what was happening in terms of where we were pre-COVID, in terms of the bus network being the largest public transport service that we have, and showing that we had just about reached a net operating surplus, which is almost unique in a situation with a metropolitan transport authority. And then just sort of summarize where we were with our business model. And our business model starts with everything going through with passenger data analysis to give us a network plan. And then from there, we issue contracts to our franchise bus operators. We monitor all of those systems together with our operational control. And that gives us two things. It gives us the ability to pay our franchise bus operators, but it also gives us a closed loop. So if we thought we were doing one service, we've contracted for it, we're operating against it, we need to reflect back how that service is operating for future changes. So that was the business landscape. Our technology landscape is very old. There's a lot of legacy systems in here, and there's a huge number of them. There's over 30 systems. It's very kind there. It says bespoke interfaces. I think there's probably undocumented interfaces would be the best way of putting it. These systems have evolved up without much of a major plan over the last 25, 30 years. Some of them predate TfL being formed in 2000. So there is a lot of issues. And when I talk about latency and performance, it's not about latency and performance of the real time systems or anything like that. It's about the latency between if you want to do a service change and you want to get into the get that out to our customers, it takes us an inordinate amount of time to actually get that through into the vehicles and into our real-time information systems. So that's one of the big issues we have. Our scale tends to cause those types of latency issues. The second issue that we have is purely the scale of our operation. We are huge. It's interesting when you see projects that says we've made a change in real-time information on one of our bus services. If you look at the figures that we have there, there's talking about 23 million miles operated in one period. So showing the dates there. And when we talk about data and data accuracy, an accuracy level of 95, 96% is easily obtained, but that means you're missing 643,000 data points in your data set. So the scale of operations is absolutely huge. And as well as the number of buses, number of stops, etc., in this model that we operate, we're churning all the time, issuing out new bus route contracts, changes, adjustments, and that was just, that's a summary from just 1 year, and that was done pre-COVID. This year is a completely, this year is a completely different set of things that's going through if I look at the challenges that we have, but I think they were probably always there, the challenges that we went through. So yeah, let me just take that one forward for you. So I think really the challenges that we have is probably set in the context of what we've got at the moment. As I've said before, our business model has been running for around 50 years with an underlying fixed bus schedule, incentive schemes based on kilometres operated and accurate real-time customer information. So coming back to that point that we raised earlier about what should be next. But really, we've got to look now at what the challenges are for the future. We know that we will have a zero emission bus fleet at some point, and the additional service control requirements that are going to come into there are going to be extremely important to us. The ability to dynamically change the number of buses operating based on new factors, not just about the demand to provide a regular timetable, but there'll be air quality, congestion, and other things that we should probably be using to flex the number of our buses that are in service at any one time. That's going to need new incentive schemes for bus operators, and advanced passenger information that makes the bus service as flexible as any modern mobility service could be. So hence the question. Flexibility to introduce a new innovation from bus companies and to have these systems fully integrated with the rest of surface transport. One of the comments on the slide I put up earlier was the fact that so many of our systems were just focusing on the bus environment because that's how TfL used to be structured. Since people like Leon Daniels and Gareth Powell have been in, we're now an integrated service right across surface, and to have the ability to integrate our bus systems with the rest of surface transport is key to us going forward. So for the customer, I've asked you some points on this, but we need to make the bus service, we need to give the customer the absolute accuracy of passenger information. I think we have done live bus arrivals to death since we introduced it. It was actually in the late 90s that we had bus stop information available, but now of course it's ubiquitous. We feed all of the apps, we provide all the data and everything else. But we think we need to do a major change on this, not so much about just occupancy, but how you late your buses and also in disruption information. It's no good just telling people nowadays that their bus is delayed. It's about what they are supposed to do once they experience that delay. So I'll give you the example of performance. I've said how many things have gone through. 2018-19, we would implement some 40 to 50 service changes of a period. In 2020, we're now doing about 10 times that figure. So that's 10 times the number of changes running around that loop. Every one of those changes has to run through that business model that I described earlier. And I said about the latency. So we need to be able to structurally change a bus route today and implement across the network tomorrow and keep the customer informed. So our current systems assume stability. They're very, very close coupled, and TfL owns the end-to-end solution, the equipment and the data. But going forward, it's what TfL wants to do is really capitalize on the data and not necessarily about the solution ownership. We will need to use open bus interfaces to allow TfL and bus operators to innovate and bring in change without rebuilding our entire systems base. I'll just illustrate that with a little example. This is the sort of technical landscape that we have where TfL is responsible for the data feeds on the right. That's what goes out into all of our passenger information. And the bus operators are responsible for operating those services on the left. And at the minute, that's a closed coupled system. It's very difficult to make an effective change in either side of that without having to redesign the whole landscape. What we need to be able to do is to allow bus operators to implement changes that benefit them. You know, we've got over 20 bus operators by definition, 10 big companies probably, and they need, they've got lots of good ideas that TfL and Londoners could take advantage of. They need to be able to introduce those technology changes, and as long as TfL gets what it needs in terms of its data so it can satisfy its customer and operational objectives, who are we to get in the way here? So I'm just coming to close my part of the presentation, and I've managed to hit the wrong button, so well done me for that. So yeah, just coming to the close of my presentation, and I would like to start just the next question for you, having heard my point. I'd like to ask you, what are the factors that you think are most affecting the bus service at the moment? I put some suggestions in there. I'd like to get your views on it, because when Luke was talking about attracting people back to the service after COVID, I think it's not so much a COVID question as a general question about what are the main drivers for people to get them to use a public transport service. I would like your views on that, please, if you could fill that survey in. So just to close my bit, what we're looking at with our systems design now is the backbone for the next 15 years. We would want to take the premise of every journey matters, which is our strap line. What it distills down to us is the accuracy, quality, and performance of data. Data is everything. So every system that is now planned has an expected life of 15 years, but built in a flexible architecture that enables us to have the flexibility with interfaces and APIs that are described. And the reason for this is that passengers, bus operators, and TfL can then provide the service that London needs. with the best customer information available, integrated management systems across all of surface transport, so we can provide a good service at a price that TfL and London can afford. So I hope that gives you a bit of an insight, and I'm now going to give Peter Bell the challenge of telling us the types of technologies that we could have that might be able to help us to deliver this. Peter, over to you.
Sorry. Yes, thank you very much, Simon. Let me just go through the process of getting my screen share up and running. Can I just confirm that that I'm now sharing my screen correctly?
Absolutely, you are, Peter. Thank you.
Excellent, good. Right, well, thank you, Simon, for explaining the challenges that TfL faces so clearly. For my part of the talk, I want to focus on two systems that Trapeze is intimately involved with and show how they will help TfL address Simon's challenges. I would also like to then show how they can create the foundation for further innovation, as Simon has indicated he needs at TfL, but also with similar transit agencies around the world. So the first of the two systems I want to talk about this morning is Adiona. So Simon talked about this myriad of systems, some of them being over 20 years old. We are currently in the final stages of developing and delivering Adiona to Transport for London, and it's scheduled to go live in Q2 of next year. And this replaces 3 existing legacy systems and provides a central repository for TfL to manage all of its non-rail schedule information. And because we're bringing all this information together, it will provide improvements in 3 areas. The first one, Simon already mentioned that they have 15,000 disruption events that they manage today. They manage that largely through an email and Word document process. And because of this, because of the nature of the systems that support it, it can really only be used for longer term disruption planning. So something like a carnival, a Notting Hill carnival. New system, sorry, I've just, yeah, sorry, apologies for that. So disruption can be, will allow short-term, currently it's only used for long-term. Adiona will allow Transport for London to also manage short-term disruptions through schedule management. Another advantage of having one system that holds all the schedule data is that these downstream systems that we supply, because we've got one view of the truth now from one system, it makes supplying downstream systems easier. And therefore we can move away from a model where we supply a complete set of schedules to actually supplying deltas. And those deltas could be quite small. It could be, we discover we've got a disruption happening tomorrow and we push just in a delta through that's related to that specific disruption. Again, giving TfL much more ability to respond to matters. And then the final thing that the new system will provide a more efficient tendering process. So the amount of information that is pushed through completely electronically will significantly increase. And I'd like to talk just through a few slides of how that will look in future. So in the new Adiona system, one of the key components is what is called the collaboration portal. So this is a central repository for tenders and the like, where TfL staff and bus operators can upload information, manage information, and distribute information. So this is a screenshot. The fourth of those folders you can see is a service specification. So that is where TfL staff will actually provide electronic versions of the specification in terms of the schedules that they will want the operators to respond to. So if we look at, this is the typical screen that a TfL member of staff would use to actually specify the service. As you can see, it's not a real schedule. What it is a specification thereof. What are the headways? What are the frequencies? They can also, as you would expect, provide information about what patterns that service needs to have and how those might vary during the daytime. The operator can take all that information, load it into their own systems, respond to the, develop the schedule, and then upload that schedule back. And they'll be uploading that schedule as a trans-exchange file. And one of the huge advantages of the solution moving forward is the fact that because it's all done electronically, as the operator uploads it, we're able to validate the business, the schedule against the service specification immediately. Operator gets very immediate feedback. Have they met the specification? TfL can then view the data as well, and this shows the screen that a TfL member of staff would use to look at, say, the blocking that a bus operator is using to deliver the service. So a significant step forward to today's email and Word process. From there, I'd like to now move on and talk a little bit also about iBus and where iBus will be going with iBus 2. So iBus is a solution that Trapeze delivered over 15 years ago. And although we delivered it 15 years ago, actually it's been subject to continuous evolution over that period. So since we launched it, we have dedicated over 800,000 hours of development in improvements to the solution. One area that is particularly important, and Simon mentioned that, is the fact that we use iBus and a subsystem of iBus called the London Reporting Database to take all the information from the operators in terms of how they're operating the services, assess that against the KPIs, and therefore that works, the system automatically works out what payments they are due or what penalties they may have incurred. Clearly, there are situations in which a bus operator may have to have varied the service for reasons beyond their control, you know, a police event or something, and the missing trip validation is a very important part of that. And one of the key things that we've managed to do as Trapeze, working with TfL, is to continue to evolve that solution to meet changing demands in London. The system has, since it originally launched, also expanded and now covers boats and trams. And one other aspect of the solution is we actually also manage today the in-vehicle hardware, and we're actually managing a churn of about 400 buses per year in and out of the fleet. And just to give you a reference for those of you who are less familiar with bus operation sizes, that's the equivalent size of a medium-sized bus operation outside of London. So quite a lot of churn that has to be carefully managed. Now, as Simon already alluded to, iBus itself was placed in an infrastructure that was well established, and there were design decisions made at the time, which were completely the right decisions given the constraints of technology at the time. But Simon has got these challenges, he needs to move on, and therefore he and his team have already indicated they'll be coming out with a tender for iBus 2. We haven't also stood still. In the background, we've been evolving the core product on which iBus builds, and we are ready for the challenge that Simon will be setting us through the tender with iBus 2. So a couple of things I want to mention. The first one is that in terms of in-vehicle hardware, we are firmly committed to the European initiative called IT for PT. And this provides an IP and modern web services based infrastructure that can be deployed in the bus using open standards, improving interoperability between the myriad of systems that you find in a bus. But we're not only doing that in the bus, we are also adopting modern web standards for interoperability in our backends. So we now use that both internally and as providing APIs to others. Over the last few years, we've really engaged with the whole concept of UX experience and have used UX designers to review how controllers use our system. And we've updated the user interface to make the process of controlling buses for a bus controller more intuitive, easier to do, particularly in a complex environment like London that Simon alluded to. You know, the scale of operation just means that the user interface has to be really good. And we've evolved that. We've deployed it in some other global cities, and we're looking forward to having the opportunity to bid for doing that with iBus 2. We talked about the fact that, you know, everything has changed with COVID, and we're all clear that we will need to get more value out of our bus networks. And the key part of that is providing data to the people who decide how the bus network is configured in future. And so in order to enable that, we've chosen an off-the-shelf business intelligence tool and integrated that so that we can give really good information back to the users of our systems in terms of how the network is operating and where we can look for improvements. Right, well, having set the scene, I'd like to talk a little bit about some of the challenges that Simon set us and how we believe that we're going to address those. So clearly, Simon alluded, frequency of updates. At the moment, the latency on an update is about a week. Simon really wants that reduced. Our next generation of products, because we're using deltas, because we're using open standards, we will be able to push a change through much faster. You know, that change could be very targeted and could actually be a change we agree today, probably deployed all the way through to in-bus data within a day or two. So a significant change to where we are today. But I think not only is that important for the reasons Simon has mentioned, but also that will give us the opportunity actually to deploy new and better services on top of that. Two of those services that we at Trapeze are actively working on are dynamic scheduling and load forecasting. So I'd like to start by talking a bit about the work that Trapeze is doing on dynamic scheduling. So for me, dynamic scheduling, very similar to what Simon was saying, is all about reallocating resources almost on the fly, reconfiguring the network. At the heart of our solution is a scenario simulator where we forward simulate the network, and that can be over a short or longer period, can be as short as 2 hours. Underpinning that simulation are new machine learning algorithms that we're developing. So two key areas that we're looking at the moment is transit times and demand. And the graph on the left there that you can see is actually a scatter graph that comes from our arrival prediction algorithm. The table also shows it in slightly different form. So we've managed to get to an accuracy when we're forecasting one stop out, the arrival of a bus to ±1 minute based on current state of the network. And even at 10 stops out, we're at 91%, which is in line with where classical algorithms have typically been in terms of their estimating accuracy. We are building on top of that also now machine learning algorithms that look at how we can do better, or how we can recommend better interventions to controllers. One of the challenges for a controller, things have gone wrong, that's the new normal. What change can they make to the network? At the moment, we're using purely simulated data because that way we know what the real answer is. And our machine learning accurate algorithms are recommending the right solution in 70% of cases. And obviously we want to further improve that. One of the interesting challenges, of course, is that in the situation today, it's actually very hard to evaluate how good humans are at doing that, because it's very hard to go back and reassess a decision. Was that the right decision? One important point I'd like to make is my personal view about autonomous vehicles is that if you think about something like Oxford Circus, it is the most challenging environment for an autonomous bus to be driving down. So my view is we won't get to autonomous vehicles in one go, but we will need to adopt hybrid solutions. If we have hybrid solutions where the bus driver is part of the solution, we're going to need dynamic scheduling, we're going to need dynamic allocation of resources. If a bus driver is taking over from an autonomous taking over an autonomous vehicle, they need to be at the right pace at the right time. I'm also going to talk briefly about load forecasting. So in the new COVID, if I want to use public transport, I want to get on a bus knowing that that bus is not overcrowded. I'm not going to be standing 20 centimeters away from the next person. Oh, actually, sorry, I've forgotten something. Our final question was around dynamic scheduling. Now would be a great time, if you haven't already done that, to answer that question. I think Luke will be blending that in, but yes, we'd be very interested to hear your views about the importance of dynamic scheduling. Sorry, back to load forecasting. Yeah, load forecasting. We're already launching this week a service with Travelline Scotland, where we will be providing in real-time load forecasting of the buses to passengers, to give them that confidence that they can get on a bus knowing it's not overcrowded. The current solution is very much based on the bus driver providing information about the loading of their buses. And it's a very good first step, particularly given the timescales in which we rolled that out. The next step for us is really to start using bring in other data. Again, Simon talked about this need to really integrate data from multiple sources. So we could bring in data, say, from mobile phones in terms of mobile phone densities around a bus stop. We can bring in data in the bus from things like Bluetooth sniffing. However, and we can also bring in data from ticketing platforms, so correlating journeys to identify where somebody has tapped in where they are likely to get off. None of these sources on their own will give us a 100% accurate prediction about what the loading of a bus in the future is going to be. And this is where a machine learning algorithm, it's one of the key machine learning algorithms that has been used over the last few years, Bayes' theorem, can really be applied. It's interesting, it's 300 years old, but actually, it's a great algorithm and one that we're looking at. My final slide, I'm just going to briefly touch on the other topic that Simon mentioned in his slides, which is really this idea that we need to bring data better together to fight things like CO2 emissions and emissions generally. Today we have multiple myriad systems that could be involved in that, but they all talk to each other using proprietary interfaces, usually highly specialized. And what I foresee in future is really a system where, particularly when we move to electric vehicles, we provide a lot more information. So the bus won't just say, I'm running late, and that might be used by a traffic management system for prioritization of traffic lights. The bus might also provide information about its loading and its battery state. So if we've got a heavily loaded bus and its battery state is not as great as we would like it to be, we might actually give that priority over other vehicles. Another example is where we have hybrids. The bus can actually inform the traffic management system whether it's operating in diesel mode or it's operating in electric mode, or alternatively, the traffic management system can actually impose a geofencing and saying, right, at this particular set of junctions, at the moment, emissions are really bad. I'd like you, if you possibly can, to switch to electric mode, even if that might mean that you're taking a short-term hit on your battery. So yes, very much about integrating different areas using smart city technology, and the open interfaces that we are integrating into our solutions will be a key enabler thereof. So on that basis, I'd like to really move on and to the question part of the session.
Thank you very much indeed, Peter. And thank you, Simon, as well. Hugely valuable insights from the two of you there. And we've got some really good questions in as well. Before we do that, I think we should take a quick look at the poll responses and get your thoughts on some of those. So, Simon, the first poll that we launched was on your behalf, looking at the next most needed piece of bus passenger information. So 64% of respondents said that it would be real-time disruption information, 30% bus loadings, for example, full or empty, and just 6% about wheelchair space availability. I don't know if there's anything in there that really surprises you, but it would be great to get your insight. I mean, from my perspective, I'm not surprised to see real-time disruption information come out as the highest of those options, but given the pandemic situation and the need for caution and social distancing, maybe slightly surprising to see just under 30% say, information on bus loading is the most important.
Yeah, thank you, Luke. I hope you can hear okay. Just put your thumb up if you can. Yeah, good. Okay. Yeah, no, I think this disruption information one, I think, is key. So much disruption information is mandrolic at the moment. Something will happen and then someone has to type in the message and get it out to people. And even if you know that your service is delayed, there is the so what factor. What am I supposed to do with that piece of information? Is it so delayed that it's going to affect my journey, and how do I move it on? So going forward, I'd like to get ubiquitous disruption information. Every disruption should be available in the information stream, and the ability to be able to capitalize on that and do that job properly. Even my sat nav in the car, it's great if something's just happened, but try telling me the roads are closed for the next 3 weeks. It doesn't do it. We need to have both of those. The instant issue goes into passenger information, tells people immediately, but that ability to be able to take the sort of more scheduled disruption, we've got roadworks here, it's going to add 10 minutes to your journey. How do we genuinely take that forward? We do a good job. A lot of information is on our website, but there's a lot of it is mandrolic at the moment. And I'm really looking to technologists to help us use AI to work out what the impacts of roadworks disruptions are and get that into the information stream automatically.
Yeah, absolutely. I mean, I suppose from a user perspective, the more seamless that process can be, the better off the experience is for any user. So looking quickly at the poll that we launched for Peter and Trapeze, are you planning to trial dynamic bus scheduling, and if so, when? 36%, so the vast majority of respondents, currently have no plans, and then next to that, 29% have plans to launch it in the next 3 years, or trial it in the next 3 years. Peter, what would you say to those who currently have no plans to trial dynamic bus scheduling?
I would say that I can understand people's concerns around it, but I think in the new world we'll be faced, where we have reduced passenger numbers, and at the same time we need to, if we want to prevent a modal shift away from buses, we need to provide the same experience. You're going to have to adopt dynamic scheduling, but I appreciate that for now it might feel a bit sort of far away. But I think the reality is we're going to have to do the same with less resource moving forward, and therefore I think dynamic scheduling is a key part of that toolkit.
Luke, if I could also add to it, I think it's essential. If you look at the balanced scorecard, if you're just looking at it from a purely money perspective, would you run vehicles that are not full? The answer has got to be no, but you still need to provide the service. But when you start looking at a more balanced scorecard, it's a hot sunny day in the center of the city, no one's traveling by bus, they're all walking around. It's a completely different scenario than it's pouring with rain and it's -2 or whatever the transport conditions are, that you need more service out there. And just on that basis at the moment, we're really struggling to get that right. So I think it's part of our landscape. I think Peter's absolutely right. It's going to be part of our world, not today, perhaps maybe not even tomorrow, but certainly the day after tomorrow. Yeah,
for sure. Thank you very much, both. We have a couple of questions to address now as well, in the final 5 minutes here. First one for you, Peter. With regards to the new Adiona platform, have you considered taking the live Google Maps feed and overlaying with the schedule so you can proactively respond to the service?
We aren't taking the live Google Map feed, and to be honest, that's a commercial decision on the part of TfL. But we do have the ability. We can have the ability to overlay disruption information onto the map, so that would be possible, and it's certainly something that we would be very happy to look at in the future. It's not part of the current deliverable, but I'm sure I will have a discussion offline with Simon and persuade him that it's a good idea.
Yeah, I guess that's not for now, so that's fine. Simon, we have a question here. It would be great to hear more about the new incentive schemes and how operators can further support using some of the existing work that they do with the Open API. One of the biggest issues that they're facing is that they sometimes come up against technological barriers and understanding on the TfL side. So what steps are in place on your side?
Yeah, I think, so break the two things apart. I'm not launching today, announcing a new incentive scheme for bus operators. Please don't think that's the case. But the conversations we've just had about dynamic bus scheduling and changing the type of service that we may want is almost certainly going to mean that we need to look at different incentive methods for bus operators. As I said earlier, we tend to, we have two basic contract mechanisms, which is the number of kilometers operated and the performance against the agreed schedule. Now, if you're making the schedule dynamic, then the performance against that schedule is going to be completely, it's going to be a different way of measuring it. And at the moment, just because of the architecture of the systems that we have, that's really difficult to make short changes. So I think that sort of answers that bit. And we recognize, we did a lot of work with our current bus operators, looking at the pain points that they have. And access to underlying data is a key point so that they can make optimizations in their world. They absolutely need more data, more dynamically, etc. They want to be able to do that. But also many of the operators, and often the quite small ones, have got innovative ways of doing things that we would like to capitalize on. And at the moment, TfL provides the end-to-end solution from the box on the bus through to service control, through to the reporting at the end. And it's time to challenge that and have an architecture that says, if you're a fleet, a modern fleet, you do everything, I'll make it up on iPads or something like that, and you're a bunch of hipsters and it's all wonderful. As long as they provide the performance data that we need and the passenger data that we need and the other integration points that we need, why wouldn't we welcome that with both arms? And I think that's a cultural change that we're bringing in, and that's going to feed into our systems landscape. I hope that answers that, Luke.
Yeah, for sure it does. Thank you very much indeed. Peter, we have I think time for one final question for you. With regards to current iBus system, one of the biggest issues at the moment, which you mentioned, is the deterioration of 2G masts in areas such as Crystal Palace and Stamford Hill, which in turn has led to the data missing and requirement for more MTV imputation. Does iBus 2 rectify this? Plus, what cellular technology will it utilize?
Okay, in terms of what cellular technology it will use, that's more a question for Simon, because that will be specified by the tender. In terms of missing trip validation, we have actually developed a next generation missing trip validation tool, which is really powerful and makes the job for the operators a lot easier. We have deployed that in elsewhere in the world, and again, we're looking forward to the opportunity of providing that as part of our iBus 2 response. So we're aware of the need to make life easier for the operators in terms of missing trip validation, and we have got solutions for that. So yes, yeah.
Yeah, perfect. Thank you very much.
There was a very good, very politic answer there from Peter. Yeah, he's absolutely right. We're dealing with a legacy communication channel system. And as I said earlier, if you get the gross figures out for the network, we get something like 96% of all data. The trouble is, I mentioned if you look at the presentation, the number of data points it means when we don't get that other 4%. 96% is brilliant in any other network. So that other 4% of missing data means that somebody in a bus operator is manually having to account for that missing data. So that's a key driver when we go out to re-tender for this system. We've got to eliminate that. In this century, we should not be having comms problems. So we're not going to specify what the comms solution should be. It should be up to our technology partners. But we have to eliminate those data loss points. We should have 100% data. And then that job for the bus operators is just really a rudimentary check that they've got their data correctly accounted for.
And actually, if I could come back very quickly, going back to actually one of the points you made, Simon, earlier, I think it's also clear that, moving forward, TfL needs to, adopt open standards. So as you rightly say, actually what comms platform is chosen needs to be a function of what's delivering the service. And that will, over the lifetime of the next contract, no doubt change. I mean, when we launched iBus, 2G was the big thing and everybody was really excited about it. Now we say, oh, that's a bit old hat. Why aren't we on 5G? Well, I mean, I don't know, we'll be on 10G by the end of the iBus 2 contract, who knows? But yeah, I think the key point again is we need open interfaces so we can change and move with the times, and that's one of the key things we're looking for.
Perfect. Thank you very much indeed.
Yes.
Amazing. Well, thank you very much both. I'm afraid we have to draw the session to a close there. But thank you very much indeed for your presentations, your insight, answering the questions that we've had. I guess we can try and look to get any outstanding questions answered after the session maybe, but entirely up to you guys, of course. But thank you very much indeed for taking part. It's been a fantastic opener for today, and obviously everybody watching, wherever you are, at home, in the office, if you're in the UK, probably at home. But thank you very much indeed for joining us, and yeah, enjoy the rest of the day. Thank you very much.